So question number 1 says a 4 kilogram block slides on the track shown with negligible friction except for a region of length of 0.25 meters, which is this region right here, and the block compresses the 8,000 Newton meter spring by 6 centimeters and then is released from rest. The block slides up this ramp and then returns back to the spring, and the maximum compression of the spring when it returns is 5 centimeters. So for A, we have to find what the coefficient of kinetic friction between the block and the region of friction is. So for the first part, we have to find the potential energy of the spring, so we have to use the equation U spring equals 1/2 K times the change in distance squared. So we get 1/2 times 8,000 Newton meters, which is given, and then times 0.06 meters squared, and we end up with 14.4 joules. So that's the original potential energy. And then it's given that the second time the spring is compressed, it is compressed 0.05 meters. So we calculate the potential energy of the second time the spring is compressed. So we end up with 10 joules. So that means that after returning to the spring, it has lost 4.4 joules of energy. So that means it passes over the friction point twice. So if you divide 4.4 by 2, that's 2.2 joules of work per pass of the block every time it goes over the friction.
Alright, so now we have to find the coefficient of friction of this surface. So we have that the length of this surface is 0.25 meters. So we take the 2.2 joules of work that we found earlier, and we set that equal to force times the distance, which is 0.25. You can solve for the force getting 8.8 newtons. So that's the force of friction acting on the block. So then, to find the coefficient of friction, you need the normal force. And to get the normal force, you use the mass of the block, which is 4 kilograms times 9.8. You get 39.2 newtons as your normal force. Then, to find the coefficient of friction, we put the 8.8 newtons, which we found of the force of friction. We set that equal to the coefficient times the normal force, and we get a coefficient of friction of 0.225. So for part B, we have to describe the motion of the block until it comes to a stop. So we have to describe how many times the block passes back and forth, and also determine where the block stops on the friction.
So as previously mentioned, the work done by the force of kinetic friction over that patch is 2.2 joules. So every time the block passes over it, it loses kinetic energy, and therefore its velocity decreases. As shown by this, it starts with 14.4 joules, loses 2.2 each time. So after 6 passings, it will only have 1.2 joules of kinetic energy left. Since this is less than 2.2, it won't make it through the 7th time. And so we set, to see how far it gets into the friction patch, we set 1.2 equal to the force of kinetic friction times the displacement, and solve for the displacement, which is 0.136 or 13.6 centimeters from the left edge of the friction patch.